In this video, we will be solving Cambridge Primary Checkpoint Mathematics Paper 2, October 2023 exam. The first question is about changing the hours into minutes. So we have 2.3 hours. So we take that number, multiply with 60, and it will produce the number in minutes. That is 138 minutes. Number 2 is about writing a number in each box to make the statement correct. So we have 2 divided by 5 is 2/5. Pretty simple. Write the name of the regular polygon with rotational symmetry of order 3. So for the regular polygon, the most common one is the equilateral triangle, and then move to the next would be the square, and then the regular pentagon, and so on. So for the rotational symmetry of order 3, then think about the shape that has 3 points or 3 vertices. So that is equilateral triangle. Equilateral triangle. Alright, number 4. Ahmed translates a shape on a square grid. Take all the statements that are always true, because this one is translation. So the new shape is actually the same size as the original shape. Okay, so the first one is correct, and the new shape is the same shape, right? Because it has to be in the same size and the same shape. The difference is just the position. Alright, number 5. Draw a circle with a radius of 4 centimeters and the center at O. Use a ruler and compasses. So when we have compasses, then we open it to 4 centimeters, and then we make a circle like this. Alright. Number 6, complete the table of equivalent values. We have fraction, decimal, and percentage. So first of all, 1/5 is going to be in the decimal is 1 plus 1/5 is 0.2. So it's going to be 1.2. And how about the percentage? We take that number and multiply by 100, which is 120%. And for the next one, 30% in the decimal is 0.3, and in the fraction is 3/10. 0.54, and the percentage is 54%, and the fraction is 54/100. Number 7, point A is plotted on the coordinate grid. Write the coordinates of point A. So A has the horizontal coordinate is -3, and the vertical is 2. Plot the point with coordinates 3/2 and -4. 3/2 is this is 1.5 this one, and -4 is this. So the point we are looking for is this one. This one is 3/2, -4. Question 8. Write a common multiple of 12 and 18. So that number has to be divisible by 12 and also 18. One simple way to do that is we take that two numbers and multiply them we have 216, and write a common factor. So that number would be 12 12 divisible by that number, and 18 also. So let's take number 3, right? 12 is divisible by 3 and 18 is divisible by 3. Oliver predicts that the girls have longer names than boys. He desires 4 questions to investigate his prediction. Tick the one that the least helpful for his investigation. So what's your name? When we know the name, then we know which one will be the longer, right? And how many letters are in your name. It is very useful to know that. Is your name long or short? So because we're asking about long or short, they are not the exact, the exact value. So we cannot know the exact number of letters in the name. So this one is just about qualitative, it's not about quantitative. So how do you spell your name? When we know the spelling, then we know how many letters are there. So there is just one. The third one would be the least helpful. So calculate. We need to change to the same denominator. We have, this one is 8 over 12 plus 3 over 12, which is 11 over 12. And that one would be the answer for this question. Number 11, take all the shapes that could have an obtuse angle. We have scalene, triangle. So let's draw a scalene that has an obtuse angle, which is this one. All right, we don't need to have equal signs here. So that one would be an example. Rectangle. Unfortunately, rectangle has 4 right angles. So that one doesn't have any obtuse angle. Parallelogram. That is this one. And we always have 2 obtuse angles. A pentagon. Pentagon is this. And it always has an angle that is obtuse. Number 12, complete the statement using the correct word. And the number 7.419, the 9 represents, we have this one is tens, hundreds, and thousands. So 9 thousandths. All right, number 13. Here is part of a sequence, and this sequence continues in the same way. Let's see the pattern in it. From 23 to 17, we subtract 6, and 17 to 11 and subtract 6. And if we continue, then the next number is going to be number 5. Draw a ring around all the numbers that are in the sequence. Alright, so I think we can, one way to do this is to utilize the, or you can take the advantage of a calculator by having the first number is 11 and then minus 6 and then minus 6, and then up to this time you just hit the enter as many times as you can. So minus 1, negative 1 does not be here. The next one, negative 7. Okay, so we're going to circle negative 7. Hit enter again. Negative 13, negative 19, negative 25, negative 31, negative 37, 43, and negative 49. Okay, so this one. Alright, so I think that we already drawn 2 rings around 2 numbers that we have to looking for. Number 14, draw a line to match each number to the correct description. For example, the first one, 136 tenths. So when we encounter tenths, then take that number and then divide it by 10. So the real value is 13.6. Similarly, take that number and divide it by 100, right? Hundreds. So 10.64. This one is 12.5 plus 0.42. So it is 12.92. 110, so that means 10, and so 7.5. 110, this one is 4, and this one is 0.36, so 14.36. Alright, so it's time to draw the line to match the number to the correct description. 13.6 is greater than 13.56. This one is less than, greater than, and greater than. So we have 3 numbers that is greater than 13.56 and 2 of them less than 13.50. The next question is 15. A clock needs 1 battery to work. The battery lasts 6 weeks. Calculate the number of batteries that are needed for the clock to work for 1 year. So we have 1 battery. We're going to summarize. So 1 battery would last for 6 weeks. So how about 1 year, right? So 1 year is equivalent to 365 days. So we're gonna change the week to day. So 6 weeks is 6 times 7, which is 42 days. So that means that the number of batteries for 365 days is divided by 44 is going to be 8.3, right? But because the number of battery cannot be any decimal, so we have to round it up. So 8.3 would be rounded up to number 9. A box contains 30 batteries. These are used in the clock. Write the number of whole weeks that the clock will work. So we have 30 batteries, right? 30 batteries. So okay, 1 battery, once again, 1 battery 6 weeks. So how about 30 batteries? So let's say that it's going to be 6 times 30. We have 180 weeks. So the whole number would be 180. Here is a Carroll diagram that describes some properties of shapes. Draw a ring around the quadrilateral that belongs in the shaded part of the diagram. So this one does not have parallel sides. So rhombus is not fit into this box. Trapezium is not, parallelogram is not, square is not, and what we left is the kite. And kite also doesn't have the same length of diagonals. So kite would be the best choice for this place. Question 17. Here are the first three terms of the sequence. Each term is made from the sum of the pair of square numbers. So for example, 2 is equal to 1 squared plus 1 squared, right? The sum of the pair. So 8 is going to be 2 squared plus 2 squared. 18 is 3 squared plus 3 squared. So that one is for the first term, the second term, and the third term. And you can notice that the position, right, the first. So now we have here the number here is also the number 1. And here we have number 2, and here is also number 2. Here is number 3, and here is number 3. So write the 6th number in the sequence. Then we have 6th, then it's going to be 6 squared plus 6 squared. And we have 36 plus 36, which is 72. Here are some numbers. Write each of them in the correct place on the Venn diagram. So for example, number 1, is this a square number or a cube number? The answer is both, right? Because 1 is 1 squared and 1 is 1 cubed. So we're going to put 1 in the overlap area. So how about number 5? 5 is not a square number. It is also not a cube number. So 5 has to be put outside the 2 square and the 2 circles or the 2 ellipses. Number 8. 8 is a cube number, but it is not a square. 16 is a square, but not a cube. 25 and 64. 64 is either a square or a cube number. The next one, number 19. Here is a drawing of a large cube on isometric paper. The large cube is made of 27 smaller cubes. And there are 3 shaded cubes that are removed. We have to draw the new one. Okay, so first of all, try to copy the first line, which is this one. We will connect 4 points. All right, and the next one is this. We will continue with this line. This time is going to be 2 points. 3 points. 1, 2, 1, 2, 3. All right, and then move here, and then move here. And then the last line. So now we already finished the top of the shape. Let's finish this side. So we're gonna go down 3, 1, 2, 3. Okay, 1, 2, 3 is here. And similarly 1, 2, 3. All right. And here actually we have the line go down and in the way like this. All right, so the new shape after removing 3 cubes is here. Number 20. Eva collects data about the mass in kilograms of 30 different school bags. She wants to use the best representation to show her data. Explain why Eva should not use a bar chart. So because bar chart is very useful for discrete data, but mass is not discrete data. Mass is not discrete data. Here are some numbers. Rajiv arranges the numbers in order of size, starting with the smallest. So write the third number in his list. So the smallest is this one, and the second is 4.31, and the third one is 4.4. Number 22. Jamila asks a group of children what food they eat for breakfast. And here is the diagram, the Venn diagram to show the number of children and what they eat for breakfast. Show this information on the dot plot. So here on the horizontal line, we have number of different foods eaten. For 0 means that there is no, there's no food that the student wants to eat. So in the Venn diagram, we don't have any number in this spot, so that one will be 0. All right, there is no children in here. For the number 1, the number 1 would correspond to the number of students who want to eat cereal or toast or eggs, and it's going to be 4 plus 4 plus 1, and this number is 9. So 9 is here, right? For the number 2, that would include the number of students that they eat both cereal and toast, or toast and eggs, or eggs and cereal. So that one would be the one in this place. This one, or this one, or this one. And take the sum of them. 1 plus 3 is number 4. So 4 is here. Alright, and the rest, there are 3 foods that student wants to eat. So that would be the overlapped area between the 3 ellipses. So that is number 2. And the number 2 is here. Alright. Question 23. Samira grows some sunflowers. She buys 4 types of sunflower seed and labels them A, B, C, and D. And she uses this table to record the number of each type of seed that grows. Next year, she wants to buy the type of seed that is most likely to grow. So write the type of the seed that most likely to grow. So because there is a different number of seeds planted, like 20 with type A and 50 in type B. So first of all, we need to change them into the same denominator. So in order to know the likelihood that the seed would grow, then we take this number and then divide it by the whole number. So 15 over 20. So for A, that is 15 over 20. For B, it is 35 over 50. For C, it is 25 over 40. And for D, it is 5 over 10. And we have to, put them, choose the greatest fraction. So make them with the same denominator. We have this one is make that one 100, right? So multiply by 5, we have 75. 35 over 50 is going to be 70 over 100. And 25 over 40 is going to be Oh, I think 100 isn't okay. So when 40 go to 100, so take let's say 100, or you can change the decimal. I think decimal is okay. 15 divided by 20 is 0.75, 0.7, and 25 divided by 40, 0.625, and the last one, 5/10 is 0.5, and choose the largest, which is 0.75. So A would be the answer for this question. Number 24, write a number in the box to complete the statement. So 3 over something divided by 2 equals 3 over 2. In order to find out this number, then we take this fraction multiplied by 2. So 3 over 2 multiplied by 2 is 3. And 3 actually is 3 over 1. Number 25. Here is a drawing of a rectangle and a square. The length and width of both shapes are measured in centimeters. All the measurements are even numbers. The length and width of the rectangle are different even numbers, of course. And the two shapes are used to make this compound shape. And we know that the area of the compound shape is 32 square centimeters. So find a possible length and possible width of the rectangle. So let's say the side of the square is A, right? And the width of the rectangle is W, and the length is L. So we have A and W and L are even number. A, W, L are even. And the area, right? The area of the compound. So the area of this square is actually A squared. And this one is W times L. And then we add them together. A squared plus W times L is going to be 32. So now it's time to trial and error, right? Because they are, the whole numbers. So let's say A is 2 because it is even, right? So let's try with the number 2. So then W times L is 32 minus 4. It's going to be 28. So choose two numbers, two even numbers that have the product of 28. So 4 times 7, right? Or 2 times 14. Okay, so 2 times 14 is okay. So A is 2, W is 2, and L is 14. All right. So the length, we're going to come to the conclusion. The length is 14 centimeters and the width is 2 centimeters. You can, have many, variety of choices. It's up to you. But this one is just an example, okay? Because they want us to find a possible length. The next question, 26. Hassan has 2.4 meters of string, and he cuts a piece off the string and gives this to Mike. So let's say this one from this point to this point is the length of string, and this portion has been cut and and given to Mike. This one. Mike continues cutting his piece of string into 2 equal pieces. So this portion is of Mike from this point to this point, and he cuts this one into 2 equal pieces, and each of them is 30 centimeters long. So 30 centimeters, 30 centimeters. But the length of the whole string is 2.4 meters, or it's going to be 240 centimeters from this point to this point. Complete the sentence. Hassan gives how many percent of his string to Mike? So let's say that the length of string that Mike received is 60 centimeters, right? So 60 centimeters divided by 240 centimeters is going to be 0.25, or it's going to be 25%. All right. Number 27. Naomi and Angelique each think of a number with exactly 1 decimal place, and both numbers round to the same whole number. Write the largest possible difference between the 2 numbers. So we have the first number, subtract the second number, and we have this one is the difference. So in order to find out the largest difference, then this number has to be the largest possible, and this one has to be the smallest possible. And both of them round to the same. Okay, each think of a number with exactly 1 decimal place, and then both numbers round to the same whole number. So let's see that if we take the whole number, because they are not talking about the exact whole number, so we have the right to choose the whole number. So let's choose the whole number. Here is whole number. Let's choose the number 7. Okay, so we have to find out a number that has exactly 1 decimal place, and when we round that number, it's going to be number 7, and that has to be the largest. So in order to be the largest, then we have to round that number down to 7, right? So that is 7.4, which would be the largest. And then for the smallest, that is 6.5. So 7.4 minus 6.5 is going to be 0.9. 0.9 will be answer for this question. So number 7 is just an example for you to find the difference. You can take any number you want, like 13, right? So you have the largest decimal number, which will be 13.4, and then the smallest will be 12.5, and then you have the difference is also 0.9. Alright, question 28. We have 10 identical right-angled triangles are arranged to make a new shape. Find the value of the angle marked A. So because 10 of them are put together to make a full, the whole circle. So the sum of all the angles inside this has to be 360 degrees. And we take that one divided by, okay, so this one is going to be B, right? So B equals 360 degrees divided by 10 is going to be 36 degree. We can mark the angle B here. So now B is 36. So A is 90 degree minus 36, and we have 54 degree is for the angle A. So 54 degree is the answer. Okay, the next one, question 29. The mean height of a group of 5 children is 120 centimeters. The model height of the same group is 125 centimeters. And three new children join the group. So now we have 8 children altogether. So the mean height of 8 children is 125, and the model height of 8 children is 120 centimeters. So we have to put a tick into the correct statement. Okay, so because we have 5 children, right? And the mean is 120. So we know the sum of 5 children. I mean the sum of 5 heights of children is going to be 120 multiplied by 5. So it is 600 centimeters. Or we can write down here the sum of the height of 5 children. That is 120 times 5, 600 centimeters. And here, the mean height of 8 children. So now we have the sum of 8 children is 125 times 8. 1,000, right? 1,000. So there's a difference between the sum of 5 children and the sum of the height of 8 children. And that would be the sum of 3 new children, the sum of the height of three new children. So that would be 1,000 minus 600, and that would be 400. So this statement is correct. The 3 new children have a total height of 400 centimeters. Correct. Alright, so how about 1 or 2? Exactly 1 of the 3 new children must be 120. Exactly 2 of the 3 new children must be 120. So there is a clue in this exercise. That is the model height of the same group of children is 125 centimeters. It means that the number of children has 125 centimeters has to be more than 1 time, because it is the model, right? It is a model height. So let's say we have 125 and 125. So at least it has to have 2 times. So when we add 3 new children into the group, then the model height now is 120 centimeters. That means that the number, so now we have to have more than two children with 120 centimeters. So more than 2, it can be 3 children, all right? Maybe 3 children that have the height of 120 centimeters, or it's going to be 2 children with the height of 120 centimeters. But let's see, the sum, the total The total height of three new children is 400. But if this case happen, then 3 times 120 is 360, is it not 400? So this one is not correct. So this one, it has to have exactly 2 of them must be 120 centimeters tall.